Good afternoon, everyone. I guess morning for some of you. We are at noon here. I'm just waiting on a few more people are kind of joining our webinar here, so don't want to be in too much of a hurry. Kind of want to give everybody a chance to uh, gather themselves, get into the webinar here. So um, most of you, a lot of you, I recognize some of the names here on the attendee list. So I've talked to a lot of you. I recognize a lot of those names. A lot of you guys are probably familiar with me, know myself already. David Zabka, for those of you who aren't aware, I've been with SDS2 here now for quite a while, since 2006. So going on 16 years now. Done a number of different things here, including support, a little bit of management, some involvement in managing development projects. I've been in sales now for about 5 to 6 years now, I believe. So yeah, this is me, and we got a full agenda here today. So this is all going to be pretty high level stuff here, right? We're not necessarily going to get real down into the technical stuff. We will to a certain extent, but it's for the most part going to be fairly high level stuff with SDS2. So first thing I'm going to touch on is what type of work is suitable for SDS2. Talk about how we do things and how we optimize for shop fabrication with our built-in Fabricator Preferences. We'll talk about our connection design, what that looks like, what makes that unique, how we're different from others. Drawings, what makes our drawings come out clean and out of the box, requiring minimal cleanup. We'll look at some of the reports that we provide, and then we'll talk a little bit about some of our integrations. So we'll build some of the model as we go. We'll create drawings as we go, kind of the whole gamut of stuff here. So first off, so what types of work is SDS2 suitable for? I get this all the time in sales when people approach me and they'll say, hey, David, I do these platforms. I do a lot of additions, adding platforms on to buildings and such. Can I use SDS2 for that? Yeah, absolutely. I mean, is it built with steel? Is there tube steel? Is there wide flange? Is it stairs built out of channels and grading and all that? Really, the answer is, if there's steel in it, yeah, absolutely. Why not? Like I said, everything from wide flange to tube to pipe, you name it. And just give you an idea, I've seen, there's stadiums built in here. There's high rises that I've seen, strip malls, gas stations, small platforms. I've seen people build park benches and detail park benches out of it, or trash gates. Everything from the smallest thing built out of steel you can imagine to the biggest thing built out of steel. So yeah, we cover a wide range of projects that you can use SDS2 for. And what makes SDS2 great, one of the things we'll focus on a little bit here, is all of these settings that we have built into SDS2 throughout the years. So we've been around for 40 years. SDS2 has been around and being developed. So you can imagine the conversations we've had with detailers and fabricators over the years, just the number of those and the variety of those. Everybody likes to do things just slightly different in their shop. That, of course, everybody's way is the best way. So in order to satisfy all those people and make things better for you guys and everything else, over the years we've just built up these settings that help optimize your shop and do things that are going to help your shop the most. So everything from material preferences to standard piece marking to the hole types used, edge distances, And then traditional detailing standards, things like using the left-hand rule on the erection views, right? So members that are horizontal on my screen are going to have the left hand or left end on the left side, and if they're running vertical on the screen, they're going to be the left end is going to be down towards the bottom of them. So of course, you can always override that, and there's always exceptions to that, but traditionally and out of the box, that's kind of the way that we work. Just on and on and on and on. So I can't even tell you, just myself alone, not including others who have been here longer than me. I've learned so much just from talking with different fabricators and detailers over the years on how they do things and how they like to optimize their workflows and such. So this picture on the right just gives you one simple example of, shear plate settings and the different things that we can do there. That's just very small sampling of, like I said, just the shear plates. So then we'll start getting into our connection design stuff. So with our connection design, we're unique from some of the other connection design software that you're going to see out there. So typically with those other software connection packages, what you're going to see is you're going to see areas where you can give it all the different values or variables of that connection. So you're going to see, you're going to see the hole rows, bolt sizes, plate thicknesses, all that, and you have to fill all that out, and then they'll give you a check and say, hey, this is good for this much load. Well, with Sds2, we take the opposite approach. You give it a load, and then it designs the connection, fills in all those variables for you, and then it does a check to make sure that it meets or exceeds the design load and reports back to you. So we take the design and we automate that by giving it, hey, this is the end result that I need. So I'm going to give the end result and we'll come up with a design for it. Not only do we design those connections to make sure the structural integrity is intact, that building is going to stand up. When we design that, we're not just designing one member to one member. We're looking at the entire node to make sure that, clearances and things like that are met, and that we are going to actually provide a constructible and erectable connection that will avoid RFIs on, hey, what do I do here? What do I do there? Type of stuff. And when I say constructible, typically what I mean there is, it's going to be designed to be built to your shop standards. Erectable means it's going to be designed for an ease of erection. And here's just a small sampling on the right here, taken from our design calculation report that I threw on there. So, and then drawings. So you can see kind of a sample there on the right, pretty basic, sheet outline with a shop drawing on there. But you're going to see, again, traditional drawing standards on here, things like your point-to-point dimensions and your material setbacks and reference dimensions for the checkers and callouts. And then it's customizable to where you can add what we call a custom property. You can add any of your custom properties, have those added to the drawings automatically. Really, we try to provide these as best we can to suit a lot of different people so that there's very minimal cleanup and 2D work here. And again, on those, going back to those project settings, there's a ton of settings in there that are going to help you determine, the appearance of those drawings and how the drawings are created, how certain dimensions are placed, things like that. So. And then reports, ton of out-of-the-box reports that we provide. Our advanced bill of material, or ABM, for all your ordering purposes, advanced mill orders. We provide that, and we'll track that number throughout the project as things are revised and changed with, like a page and line number from that ABM. That's pretty robust there. And then you get into things like material summaries and cut lists and bolt summaries and bill of material reports. And then we even provide a customizable tools. So we call it report writer, report creator. So you can go in there, modify out of the box reports, or you can even start reports from scratch. So there's just a ton of data within SDS2. Really, I always like to think of it, it's more than just a drafting and detailing tool. It's a 3D database, and there's just so much information in there that we can pull out in these different reports and things to help us be efficient. Okay, then talking about some of our integrations. So if I've got a detailing software, but it doesn't integrate with these other tools that I'm using, well, that detailing software isn't of a lot of use to me. So we always put a big spotlight on our partner integrations. Some of those others that you'll run into, or some of those fabrication management partners you'd run into today or might see, are InfoSite, P2 with the barcoding, Radley Corporation, Steel Project, Strumis, Tekla Power Fab for your inventory, your production control, things like that. We work really well with all of those guys. Strumis, we output their I believe it's a BSWX format, their native file format there. And then Tekla Power Fab, we communicate with them via XML and IFC files. And then if you're still kind of old school, you might just be using a simple KISS file still to transfer information to any of those also. So, and keep in mind, these are not the only partner integrations that we have. These are just some of those that I've highlighted to put on here. There's a lot of others out there that I won't show just because we don't have time or the space on my slides here. And then we're going to see other integrations to design and structural elements. So with Revit, IFC files are great. We also have a free plugin to Revit that's going to transfer the main structural members to or from Revit and SDS2 in a cleaner format. Core brace. So if anybody's used core brace, that's a kind of a proprietary seismic bracing connection. So there's a lot of design that they do that has to get transferred to the detailer, and we have a plugin with them that creates their connections for their core brace on there. Makes it a lot easier on the detailer. And then Durafuse frames, very similar. This is a proprietary seismic moment connection that they can pass their design information to us to make creating the connections easier in SDS2. Same with MyTech and SidePlate, and then Simpson Strong Tie is very similar as well. Hexagon, we have a plugin to S3D that takes our connection design into S3D. And then RISA, we've recently been developing a more direct communication with RISA, so we can directly import their native R3D file formats and the end reactions that go along with that. So, and again, these are just some of those. Anything that can do like a CIS2 file or IFC file, SDNF file, we'll work with as well. So we've been doing this for a long time. And then you get into your automated equipment, your CNC stuff, your beam lines, some of your robots now, your automated assemblers, things like that. So Bentech is very popular recently for the handrail type of stuff. So is Lightning Rail for the handrail layouts. And then you got, Control Automation, Dieto, Peddinghaus. Those are some of the bigger players, or Lincoln Electric with their Python X. Vortman, Siemens got the automatic beam assembler that assembles and welds things together for you. So yeah, we do a ton of different integrations to make your shops run smooth there also. Okay, so let's hop into SDS2 a little bit here and kind of take a look at what some of this stuff looks like. So kind of starting just on my home screen here and having a look at the project settings. So this is where I started off and talked about how we've collected all of these different settings, Fabricator preferences throughout the years that optimize the fabrication. So, within this project, we've got on the left side Fabricator settings that are specific to that and that I've been mentioning. We also have job settings. So, job settings, different projects are going to have different requirements, might depend on where it's located, might depend on what design method the engineer used for that project, number of different things that you'll see on the right. So this is where we'll go in and we'll set things like our connection design method. How do we want the automatic end reaction calculated? Is it 50% uniform allowable load? Do we just want a minimum connection from our schedule? Number of different things there. On the fabricator side, we're looking at things like clip angle settings here. So what's the gauge to be used? How do I want the holes staggered? What's my edge distances? Do I want to extend those connections and cut flange flush to fit another row of bolts in there? Do I want to combine the clip angle where there's a vertical brace framing into that same joint? I have a checkbox for that. Number of different things in there, and then you get into things like our preferred connection material sizes. So this is going to kind of be some of your miscellaneous type of materials that you typically have in stock at the fabrication as the fabricator. So basically it's a table of the sizes of angles that I want the software to use where it sees fit. Same with WT sizes, flat bar sizes. So what do I typically have in stock that I want SDS2 to use? And then this plate sizes, this is strictly a plate thickness. So obviously, plates are going to come in sheets rather than a stock bar or what have you. So what plate thickness do I typically have in stock and do I want to use for these different situations here? And then you get into stuff like standard piece marking, okay? So in this particular job model that I will open here in a minute, I've got bolted welded clip angles, so I'll just open that so we can check that out, and we'll go here. So that's not the one that I wanted, so we'll do single clip angles. I thought I had this filled out already. Apparently I did not. So anyway, what we do here is, based on your bolt size and the kind of the scenario that we have selected here, we can set up the standard angle size, hole locations, and then the chart below is, on the left, it's the number of rows that are going to be in that angle. Across the top is the gauge outstanding leg. So we can fill this chart in appropriately that if we've got 2 rows of bolts and it's a 1 13/16 gauge, I find that, punch in what I want the piece mark to be, and when we design those connections or those materials are created in the model, they're going to be assigned those standard piece marks that our shop would need. So. Then you even get down into, detailing presentation. So how do I want my different members detailed? Do I want to show design loads on those details? Do I want to show capacity of those connections on there? My square cutting beams where they're sloped, so I don't have to have a bunch of bevel cuts where they're not necessary. Few handrail options, stairs options, how those are detailed up. Then you get down even into things like, do I want to cloud holes where there's slip critical bolts, and just down to a lot of minutia, but stuff that is very important to that drawing presentation and making you guys as efficient as possible. So a lot of information in there. So, and that's all going to affect, the better I set this up front, the more success I'm going to have modeling, the more success I'm going to have creating those drawings and getting those as clean as I can out of the box once I get to the drawing creation phase. Okay. So I do have my model open already here, and you can see just a pretty basic platform. I've already got, you know, my anchor rods in there. I've got kind of that first up on the platform done already. Some basic, just a 2-line pipe rail in there, nothing too crazy. I am going to come up here to this kind of second level of this platform, and I'll finish off some modeling up here. So to help me with that, I have imported some PDF drawings, design drawings ahead of time, and that's just going to be a 2D drawing, you know, design drawing. It really is great to give me a heads-up display in my model. I know a lot of detailers are very particular. Understandably so, they've got to get it right, so things are fabricated right and they go up right in the field. So wouldn't necessarily suggest you can snap to the lines on these design drawings. Not a lot of detailers are going to trust that these are 100% accurate. So it's really great to do a heads-up display to get me the information here, so I'm not moving from screen to screen to screen to find my drawings, to come back, or, you know, flipping through physical prints all the time. So really great for that. And you know, there is a lot of layout work. So you know, typically you're going to spend more of your time going through design drawings to find your information and send your RFIs and that than you are going to spend modeling in SDS2. And you know, I don't always like to be transparent with everybody. So yeah, there is typically quite a bit of time that can go into laying stuff out. But when I have all the information, it's fairly painless. So, you know, obviously, as I input these, I'm going to need some lines or some points to snap to in certain cases here. So in order to get that, I use my construction line add command. And what I'm going to do is I have my dimensions here. So I'm going to use a little point locator. We call it base off a construction line. This is just going to allow me to go in and type in how far offset I want these things. So I started there at grid 3, and I'm just going to work my way to the right to make sure that I get everything in there exactly as it needs to be. So we go to 5'9", 5'9" again. The 3 foot 5.5 is already there. And then I'll do the same thing down here from grid B using my dimensions on the right. So 4'4" 5/8, 4'3 1/4, and then our 4'3 1/8 is already there. Then we got a couple oddballs here, it looks like. So we go 4'9", 3'6 1/2, and then our others is already there. Okay, so not too bad there. I could come in and add the construction lines over here for my horizontal braces if I wanted to. The points are really already there where they intersect, but if I wanted to, you know, I can add those by picking 2 points as well instead of doing the offset. So a number of ways to get your construction lines, your layout lines in there easily. And then I'm ready to start adding my members. So these are beams. Add beam. I'll put in my wide flange members first here, kind of my main framing, W10 by 30. Oops, I'm going to go from, I forgot to get a construction line over here on the left. So that was my fault. Let me go back here. I'm going to go a minus 3'4 3/4, or the other thing I should be able to do is use a different point locator. We have intersection construction line and member. That's going to snap to a member line and a construction line. Okay, and then I forgot to change my section size up here. I'm getting ahead of myself. So W10 by 30 across the top. That's going to get me my correct section size. I can always come back and make adjustments to those ones that I goofed up later. where I have identical members, I simply do a middle click at the left end, gives me an identical copy, and I don't have to pick 2 points, allows me to get those put in with 1. So I can middle click over here, the 10 by 30. Then I got these other couple here that are framing horizontal. And then I can put in my channels here. So my channels, I'm going to have a little extra to worry about because I got to worry about the toe direction. Okay, so if I'm working with the left-hand rule, the toe's over here, it's going to be, the toe direction is going to be out. And I do have a little option here for the toe direction out. Okay, so I get that one in there. Middle click, repeat that one. And then I can come up here to these others. Looks like these are toe in. Same over here. Okay, I goofed up over here before I input this beam with the really wide flange. I didn't change the section size, so anytime you got to edit something, a simple double click will bring up the edit window for me to make changes. And if I recall correctly, these angles were a 4x4 by quarter. That was from a design note. I'm using the little Z offset here to go -3 inches into the screen. So they'll be -3 down from where I'm actually inputting these here. Get my point locators right so everything goes in nice. Okay, so input's not too bad. You can see here, I'm getting angles that are shop welded to the supporting member, and they're going to be shop bolted to the supported, almost like a shear plate, but with angles. So what happens, or the way SDS2 comes up with this connection, is it's looking at the framing condition here in the framing situation. So it knows that this is a channel. It knows it's framing to this wide flange beam, or same thing over here. It knows I'm a wide flange here. It knows I'm framing to a wide flange over here. And what it does is it comes out here to the project settings and it looks at this auto standard connections table. So this is a big table of all our different framing conditions. So I have from beams to columns, and then it gets down really specific into what material type is framing to what material type, and then what's the kind of positioning of everything. Is it framing to the web? Is it the flange? Is it skewed, perpendicular? All that. So if I were to look from beams to beams, channel beam to wide flange beam, framing to the web perpendicular, I see I'm getting a clip angle. If I double click on that, that gives me my different specifications or variations of that clip angle on the right side. And you can see I have that set up to be bolted to the supported member, welded to the supporting, and it's only on the near side. I could do both sides, far side, bolted, you know, attach it to the supported or supporting member. I can do shear plates, bent plates, end plates, number of different connections within here that I can set up for SDS2 to use. Now, that's taken full advantage of kind of the automation and using the auto standard connections. So what you do is you're going to set that up with your most typical used connection on the project, or what you prefer for fabrication. And then where there's one-offs and areas where those won't work, you can double click that member. You have a left end, you have a right end, and then we have a connection type in here for me to override that. So if I did decide in certain cases here I wanted a shear plate for whatever reason, simple matter of changing that to shear in the member edit window here. I'm going to go back to auto standard so we get consistency. Okay, and then all of these connections, as they're designed and as they're created here in the model, are going to get design calculations with them. So kind of talked about that structural integrity and how we SDS2 does things in the PowerPoint. This particular project, I have this set up to give me a minimum setup. So what that means is there's another table out here in project settings. So it looks to this schedule of minimum, in this case for structural members. It looks at what nominal depth is in here, chooses the bolt diameter based on this table then. So for W10s, we're going to get 3/4 bolts, 2 rows, top of steel, the first hole is going to be 3. And that's what we're getting here. The shear load reported here is the capacity of that connection. If there are specific design requirements, specific loading, let's say we need 25 kips in that case, I increase that. We get what we call a failed connection, or SDS2 can't come up with its own result in this case. Probably struggles to find room in this shallower beam with that higher load to come up with a true result. If I go 20 kips here, we do get that connection. And if I just look at the expanded calcs, so that's going to generate a PDF for me. It's going to have all the information about my framing condition. It's going to show me my limit states. It's going to give me the extended calculations then that show the actual longhand results of how we arrived at the result or the design that it did. Okay, so basic information on that member. Here's your section properties. Left end information. We were looking at the right end of that member, so I'll just hit the right end over here in the bookmarks, skip to that side. We get our connecting nodes. We're framing to a 12 by 35. You know, here's your design loads, your reaction. Then you get into the connection details, bolt sizes, row spacing, all that. And then we come to our limit state table, right? So in here, you get your calculation that's being checked on the left, calculation number that refers back to a cover sheet, which is a separate report that we can run. Our unity ratio, so a lot of your approving engineers, checking engineers are going to be familiar and comfortable with that unity ratio. You get the actual result for the capacity of that check, and then you get your AISC reference. If you really want to dig down further, hit your expanded calcs over here in the bookmarks, and we see the actual numbers, the actual formulas, and how SDS2 arrived at the result that it did here. Okay, so there's just a ton of information in there. So that's kind of pretty high level look at the connection design stuff. Now I want to get some railings in here up top also. So I'm gonna kind of do this a couple of different ways. Now I did all this layout on those construction lines. I don't want those to clutter up what I'm doing here with my rails, so I'm gonna get rid of those. You can also save and load those construction lines. So to make it easier, if you find yourself erasing and having to re-add construction lines, save those off. Okay, so you can see some additional blue ones that popped up here that are going to help me add in my handrails. I can add individual handrails, but what I'm going to do here to start with, I'm going to use this add flat handrail command. And what that's going to allow me to do is that's just going to allow me to go around here and pick points. And I could have picked my points along the center line of the beams and specified an offset. I don't want to do that. I just want to do a 0 offset. Since I already did that with my construction lines, kind of a personal preference. I find that slightly easier. So this is the way that I'm going to do that. And what I'm going to get here is I'm actually going to get, I should have added another one in here, but we're going to just go ahead and eyeball it here for our purposes, what we're doing here today. Give myself a little clearance there. So what I get here when I run this flat rail is I get a max rail length, I get a minimum splice clearance, different things in here. So what this allows me to do is say, hey, I made this kind of outline or layout of rails, I don't want each individual rail to be, you know, that full section. I'm only going to fabricate them in 20-foot max sections or what have you. So it's allowing us to split it up there. And then we have a setback from the start point, from the end point. You know, do we want a PN? Do we want to finish it with a post? Different things there. And then how are we connecting? Base plate, I'm gonna do a clip angle in this case. So this is a really quick way to input those rails, especially on a lot of those industrial projects that you're gonna see where they don't have to be exactly pretty, all that good stuff. We can use the rail layout here to do some of that. Can take it a minute. That's a lot of rails to create. So something to mention that Sds2 always does in the background is it's always doing piece marking as you create the model and build the model. So what I mean by that is every material that I look at here, so in my right click menu, when I right clicked on that, I can see an HSS 322. That's the piece market assigned for that material. Where there's identical materials, it's going to give those all the same piece mark. So I bet if I hit HSS 317, that's the elbows. I bet I'm gonna have some identical ones over here. You can see we're highlighted as well. So there's no kind of post-process thing to have some material marks assigned to them. It's always done as we build this in order to keep things up to date always. And then you can see it's not, you know, one rail all the way along here. We did split this up into individual rails. Right now, the way this works, we kind of always do a splice here, like a welded splice on that with the layout tool there. I don't necessarily want that, so I am gonna kind of delete this and show you a different way of laying these out. There's also post-process tools for this, so I could, you know, introduce new splice locations, move splice locations, redo the spacing on my posts, number of different things that I could do there. If I go back to my plan view, what I want to do is I kind of want to more evenly space these amongst different points. So, you know, one of the things that's really powerful with Sds2 is our APIs. So we actually have two APIs. We have a API that's written in a Python language. We also have an API that's written in a .NET language. We have a lot of generous users out there who like to share those parametrics amongst other users, and they've created some along the way. We can create buttons for those, quick keys for those, different things here. So I actually have one laid out here, construction line linear array. So what that allows me to do is that allows me to pick 2 points, and then I can say, you know what, do an auto spacing or different ways, and I'm gonna say give me a maximum spacing of 20 feet. And it goes ahead and separates that into equal spacing. You probably noticed the button got added over here on the left, so I can hit that again to do this top side because that's going to be a little different. I'm going to change these to red. That way I get a little differentiating in there. And then I probably got to go between A and C and do the same thing here. So I'll go A to C, 20 feet, okay. So this is going to give me a little bit more equal spacing amongst my rails. And I am still going to use this quick layout tool. And there's a reason for that I'll explain here in a second. So this one I was going to the green ones, offset 0. So I'm just going to right click there. I just want that single one, and I'm going to do this a little different. So I'm going to say 6 foot max spacing, start setback. I'm going to go 1 1/4 with a P end, 1 foot to the first one. Finish setback is 1 1/4, P end 1 foot. And then I believe my walk side, I actually want to change to the far side, and I still want the clip angle connection in there. Okay, so that gives me a nice rail there. And then I'm going to come up here. I'm going to go ahead and do my rail up top here. Okay. Okay, so I'm really using that layout tool so that I can take advantage of this start setback and the finish setback and some of the things in there that are going to help me out. And then I can do my rails here. So that's going to create that clearance for me by using the offset and taking advantage of the offset. That creates the clearance for me between the two individual rails that I'm building in there is really the goal of what I wanted to accomplish there. And then it's a matter of, you know, anything that I build, anything that I create within SDS2, I can make copies of that and whatnot. So I could have continued using that rail layout command, but it's probably easier now in this case to do a member copy, and I can copy it from this intersection point to the next intersection point, and then finally to my point over here. That rail we're seeing down below is from that kind of first level of the platform. So I could adjust my clipping plane or my depth check down here so that I didn't see all that stuff down below. Wasn't necessarily too concerned with it. Okay, and then I'm going to come up here. So you can do a right-click menu. Otherwise, you know, you have your contextual ribbon up here that you can use also anytime you select something within SDS2. And I realize I just I picked the wrong points. I should have been using my red layout points for this one, I believe, right? And as I tell everybody, you can never fix user error. So I would want to go back and do that, get the right points picked. But this gives us an idea how we can do those things and get our individual rails in there pretty quick, like doing things like that. So I've kind of combined, you know, some layout stuff, talked about parametrics and creating buttons for those to make everything a little bit smoother, a little bit easier for us all. So, and then, you know, then we can start getting into drawings and reports and output of this stuff. So what I'll do next, I'll go ahead and I'm just going to detail up the members, detail this project up. So this is going to go through and create, I might just detail the columns for time purposes. We are running a little short on time, so I can use my hide options to hide on a number of criteria and only create the drawings for those particular things then. Okay, the other thing that's nice is, you know, I could use my selection filter down here, set that to columns, and I could save off a selection list. So I'm just going to call this selection list columns. And then if I were to go to that same list where I detail members, or we'll see this list in a number of different areas, when I load that, okay, now it saved that selection and it loaded that particular selection right up for me, as you saw there. So different ways of doing that stuff there. And then we can hop into Drawing Editor. This is the 2D portion of the program so that we can kind of see what's going on here. We have our details. Here's out of the box. Everything in here, we can click and drag, add our own dimensions, do whatever we got to do in here. Obviously, when you get into some more complicated, more complex connections and whatnot, you're going to see a little bit more cleanup time on that, just harder for the computer to figure out and get everything exactly the way it needs to be. But overall, pretty good, pretty clean. Like I said, we try to follow traditional detailing standards on most of this stuff, so it looks familiar and whatnot for you guys. So then we're going to get our individual details, and we're going to combine those on what we call a detail sheet. Now, I could do this manually for each one of these, and just to make sure I get the right order, I'm going to start here with this bottom left one. It's C65. Okay, so I'm using quick keys now. I hit SC on my keyboard. I add C65. That brings the bill of material information over here automatically to fill that out. I got a total weight down here. And then, okay, these are kind of temporary piece marks, but what I'd want to do there then is update that based on the sheet number. So I can hit what we call save reuse, and we have this change marks function. Okay, auto change marks, the next drawing name is going to be 2. Okay, and then what I do is I get a set of criteria on how I want to change those marks. So do I want to change those marks based on, in this case, I'm going to do a user character. Maybe that's a job number. Second thing is going to be the sequence. Third thing is going to be the member type designation, in this case C, and then the sheet number is going to be 4. So I go ahead and hit OK. What that did, you see I'm now at drawing 2 instead of 1. It threw away that detail because it was already added on sheet 1. And if I go back there, we see that piece mark is updated. 57, 1 was the sequence, C was the member type, and then 1 was the sheet name. And if I look back here in modeling, I can turn on my display options and show you in my display options the member piece marks. 57-1C1 was updated. So I know a lot of you prefer to have things loaded on sheets in a very specific order. So again, kind of using a combination of tools here. What I did here, I pulled this up. This is what we call status display. This is going to hide anything that is not detailed, and then whatever is on a sheet already, it shows me in magenta, makes it a little transparent. What I've done is I've created this parametric that lets me pick members, and it's going to create the sheet and auto load the sheet for me. So that allows me to pick my sheet outline, and then in a very specific order, you can see that piece mark updates and the color updates to indicate it's being loaded onto the sheet. And I just go ahead and pick those in a very specific order how I want them. Okay, I'm done. Look back in Drawing Editor and I hit open. Look at my detail sheets list. Now I've got all the way up to 14, and if I filter through those, we can see piece marks all updated on here nice over in the bill, and we have everything loaded up nice. Okay, so then final product. What are we going to do with the final product? Well, we go to our project setting, or excuse me, my home screen, go to my export. Here's all my exports. So do I need, the CNC information? So we've got our CNC, we've got our 3D exports, we've got our Tekla Power Fab, we've got our KISS if we want, our steel projects, our Strumis BIM review, number of different things out there. I'm just going to do my export to a PDF drawing, and I'm going to send all those out. Now I am running out of time here a little bit. That's okay. I'll send this to my desktop. So if I do a complete package where I have the erection sheets, detail sheets, submaterial sheets, or gather sheets all created, all the individual piece marks on those sheets will be hyperlinked. I don't have the full package, again, time constraints here. So a couple things I do want to point out, however, we do a table of contents here, so nice, easy navigation. You have your sheet number, you can go to that full sheet or drill down to the individual detail on there. And all of this text is searchable as well. So if I hit my search over here, and gosh, I don't even have a piece mark. So let's say I search for typical, see if I have any typical notes in there. Sure do. Gives me the results of that, and then I can click on those in the results. So all this is searchable. In order for that to happen, we just need to make sure we use a true font that's available. So if for some reason a detailer has an old font holdover, something that's not a true font, you're having trouble searching these documents, we just need to make sure that we're using a true font when we create our details in order for this to be searchable. So, you know, just to give you an idea then here, I will turn off my status display. I will detail up my material just so I get, then I'm going to run some different reports and we'll kind of finish it off with that. So I'm going to detail some material that is not my main material. We'll run a couple reports to show you that, and then I will kind of turn it over to questions here a little bit. So let me actually turn off my piecemarks, a little less cluttered screen there. Okay, now I have reports up top. Number of things. I can run shop bolts, field bolt summaries. So let's say I run a field bolt summary, give you an idea what that looks like. Okay, there's a basic field bolt summary. All your counts, types, anything in there. We could run things like, say, a material summary by detail. So this is going to separate out by the details. So all those columns that I had detailed, that's going to separate the information out there, give me the material summary based on my selection there. And then any of these I can run using our nice Excel reports tool over here. So what that allows me to do is just send some of those out to Excel, a little bit nicer format than just that basic kind of text dump that you saw there. I don't know, maybe I want to run a plate report by thickness. And let's see here. It's not going to let me create the, let's go back to my material summary. There we go, select by detail. I'm going to create the Excel report. Again, I have to run that selection. It's going to open my Excel report for me. So it just gives me, you know, sends that out to Excel, gives me that little bit nicer format for the reports there. So that's kind of what we got for today here. I'm about at an hour here, so I thought we'd have a little extra time here to get through some extra stuff. We didn't, but you know, we'll cover it in future webinars here, make sure everybody gets the information that they're after. If you do have questions here, I will definitely stick around. I will answer some questions. Just hit those or type those in the questions pane over on the GoTo webinar panel that we have up. While you're kind of putting your questions in there and collecting your thoughts, just a couple other things to mention here is we do have some exciting upcoming events. So if you are a customer thinking about buying SDS2, whatever, let us know. We would love to see you at our event that we put on every year in conjunction with our users. We call it Sds2 Summit. So that's October 19th and 20th down in San Antonio, Texas. We got a really nice spot right on the Riverwalk. I'm excited for that. And then we always attend the FabTech show. So this year it's going to be in Atlanta, November 8th through 10th. That's always a really big show. So take note of our booth number here, B9770, so you can make sure you find us there at that show if you're going to that. So let me check out. I do see some questions coming in here. And again, I don't necessarily want to get real technical on some of this stuff. If there are super technical questions, our support department is best for that. Let me see if we got some stuff here I can answer quick. So yeah, like a connection without using the auto standards. So that's anytime something isn't created automatically by SDS2, you can create any piece of material that you need just by picking 2 points, and it's going to add a piece of material, whether that's a angle or a tube or a channel or plate, flat bar, whatever you have, we can do that, not a problem. Let's see. Somebody's got a question about sheet numbering in question with zones. I'm not exactly sure what's being asked there. If you do want to get more information on purchasing a license, I see a couple questions on that. I would suggest emailing sales@sds2.com or give us a call, 888-883-2492. And then, so another question on kind of the licensing here a little bit is how many users can work at the same time. So if you purchase one license, that's one person at one time. We do use a email login based license system. So, you can install that SDS2 on as many computers as you want. Just one person per license is going to be able to run that at a time. So if you needed multiple people to run it, you'd have to purchase multiple licenses. How can we find out what's in store for the SDS2 Summit? I do know we are in the process of coming up with that agenda and what that's all going to look like. So I think we're fairly close to finalizing that, not completely, but I'm sure our marketing team will be sending out emails about that and what that fully looks like. Otherwise, we do have a page specifically for SDS2 Summit on our website to check out periodically to find out that. And then here's a question. How do multiple users work on the same model at the same time? Great question. So this is another kind of unique selling point for SDS2 and something that we do differently. So SDS2 is actually a true multi-user model. And really what we mean when we say that is every time I perform an action, whether it be I add a beam, I add a piece of material, whatever it is in that model, that information is automatically saved and written to disk. Okay, so what that means is I never have to worry about saving the model. If I have a power outage or whatever, I don't have to worry about, boy, when was the last time I saved that, because it's always done. What that also means is if I'm sharing the model, so say I'm in a multi-user environment where I've got 3 detailers working on the same model, what I do there is the data would be hosted on a server. Your individual detailers would be working at their client machines. SDS2 is installed and it's running at the client machines, but it would be set up to be where it would communicate and write the information to the server when things are done. So every 3 detailer, they're going to see what the other 2 are doing in their model live as it's done, and that also eliminates a lot of issues with having to check out a local model and then push it to the central model and worrying about, well, am I pulling the most recent data from that central model, and when I push back, am I overwriting something somebody else did? With the way we work, since it's all live, kind of takes care of some of those issues that you have when you're pushing and pulling data manually. So great question. Okay. Looks like some of our questions slowed down here a little bit. Like I said, I don't want to necessarily get into like real technical support type questions. Those are better off sent to support or a separate conversation here. So if you do have some more technical questions, here's the support email address on the right here, support@sds2.com. If you have sales questions, I'd be happy to answer some of those, or our account managers or sales staff would be happy to answer that. sales@sds2.com. You can reach us by phone there with the phone number. And then last thing is always just thank you. Thank you all for attending. I appreciate all your time. I know you guys are busy and have full days typically, so anytime we get from you is very much appreciated. Thank you, and we'll see you at the next time. Enjoy the rest of your day.